Now the radiation gets down to the surface of the Earth, and when it gets there, once again, it gets reflected or it gets absorbed. This isn't rocket science. What causes it to be reflected is the surface characteristics, and we quantify it with a little number called an albedo. And the albedo is a measure of how much of the energy is reflected. And you can see in this diagram that the planetary albedo is around about 0.3. So not very much of the total radiation gets reflected off the planet itself. The planet tends to absorb radiation and then re-emit it as long-wave radiation that will eventually make its way back into space. But what's interesting with this diagram is how similar the albedo is for trees and grass compared to asphalt or tar and concrete. Around about 0.1 to 0.3, again absorbing most of the incoming radiation. In contrast, white paint can have a reflectivity of 0.9, and a highly reflective roof can have a reflectivity of 0.7. So we do have the technology to create highly reflective surfaces. Once again, reflecting the short wave or the long wave back into the atmosphere doesn't necessarily mean that we've gotten rid of it, because once it's back in the atmosphere, it can be absorbed, reflected, etc., by the particles and the gases and the clouds and so forth and so on. Clouds, of course, being water vapor particles.